Hello, my name is Legolas Jan Eda Chavez. I am from 8 Onyx. So today I am explaining my understanding regarding the following topic. The following topics: monomial factoring and factoring by grouping. From what I understand, when we are talking about monomial factoring, we are dealing with these two terms: prime factorization, prime factorization, breaking a number down into the set of prime numbers which multiply together to result in the original number. Greatest common factor, aka GCF, largest term that divides each of the terms. What is GCF? The GCF, aka greatest common factor of two or more numbers, is the greatest number among all the common factors of the given numbers. Example, let us find the greatest common factor of 18 and 17. Solution. First, we list the factors of 18 and 17 and then we find out the common factors. Now, what is monomial factoring? Factoring monomials is a process of breaking down a monomial into smaller terms. Although factoring a polynomial usually shortens the polynomial, factoring a monomial expands it. For example, the expression 2x is a monomial but the expression of x plus 2 is a polynomial. Now, what is a monomial? A monomial is an expression that is the product of constants and non-negative integer powers of x, like 3x squared. A polynomial is a sum of monomials like 3x squared plus 6 minus 1. To factor a monomial completely, we write the coefficient as a product of primes and expand the variable part. For example, to complete factor 10x squared, we can write the prime factorization of 10 as 25 and write x3 as xxx. Therefore, this is the complete factorization of 10x3. 10x3 equals 25xxxx. Now we are talking about factoring by grouping. What I understand from it is just like it says, factoring by grouping means that you will group terms with common factors before factoring. As you can see, this is done by grouping a pair of terms, then factor each pair of two terms. How do you do factoring when grouping? Step 1. Group the first two terms together and the last two terms together. Step 2. Factor out a GCF from each separate binomial. Step 3. Factor out the common binomial. Note that if we multiply our answer out, we do get the original polynomial. Now, what is the importance of factoring by grouping? This method is often called split the middle, since it endeavors to create two middle terms which will make the factoring process easier. What does grouping factors mean? A factor whose levels separate the sampling units into groups whereby no subject is exposed to more than one level of the factor. Now, after we talk about that, what is factoring? Factoring is to write an expression as a product of factors. For example, we can write 10 as 5, 2, where 5 and 2 are called factors of 10. We can also do this with polynomial expressions. How do we use this factoring by grouping? First, look at the equation. If If you plan to use this method, the equation should follow a basic format of ax squared plus bx plus c. This process is usually used when the leading coefficient, aka the a term, is a number other than 1, but can also be used for quadratic equation in which a equals 1. Example, 2x squared plus 9x plus 10. Step 2. Find the master product. Multiply the a term and the c term together. The product of these two terms is referred to as the master product. Example, 2x squared plus 9x plus 10. A equals c. A equals 2, c equals 10, ac equals 2, 10 equals 20. Separate the master product into its factor pairs. List the factors of your master product, separating them into their natural pairs, the pairs required to produce the master product. Example, the factor of 20 are 1, 2, 4, 5, 10, and 10, and 20. Written in factor pairs 1, 20, 2, 10, 4, 5. Step 4. Find the factor pair with the sum equal to b. Look through the factor pairs and determine which set will produce the b term, the middle term, and the coefficient of x when added together. If your master product was negative, you will need to find a pair of factors that equals the b term when subtracted from one another. Example, 2x squared plus 9x plus 10. b equals 9. 1 plus 20 equals 21. This is not the correct pair. 2 plus 10 equals 12. This is not the correct pair. And 4 plus 5 equals 9. This is the correct pair. Step 5. Split the center term into the two factors. Rewrite the center term, breaking it apart into the factor pair previously identified. Make sure that you include the proper signs, plus or minus. Note that the order of the center terms should not matter for this problem. No matter which order you write the terms in, and the end result should be the same. Example, 2x squared plus 9x plus 10 equals 2x squared plus 5x plus 4x plus 10. Step 6. Group the terms to form pairs. Group the first two terms into a pair and the second two terms into a pair. Example, 2x squared plus 5x plus 4x plus 10 equals 2x squared plus 5x plus 4x 10. Factor out each pair. Find the common factors of the pair and factor them out. Rewrite the equation accordingly. Example, x 2x plus 5 plus 2x plus 5. Step 8. Factor out shared parentheses. Therefore, there should be a shared binomial parentheses between the two halves. Factor this out and place the other terms in other parentheses. Example, 2x plus 5, open parentheses, close parentheses, x plus 2, open parentheses, close parentheses. Write your answer. You should now have your full answer. Example, 2x squared plus 9 plus 10 equals, open parentheses, 2x plus 5, close parentheses, open parentheses, x plus 2, close parentheses. The final answer is, open parentheses, 2x plus 5, close parentheses, open parentheses, x plus 2, close parentheses.